Hello, this video is for anyone that was absent today, Tuesday, April 27th. I forgot to record my Google Meet because there was a lot of other things going on, so I'm making you a private video. Aren't you special? Okay, so this is the end of lesson 3.2. This was just one last thing on this lesson. So we look at these directions and it says evaluate g of x equals ln of x at the indicated value without a calculator. So the first thing that you need to, and I'm just giving you an extra example, something that hopefully is easy for you to understand, something simple, like if let's say we had log base 3 of 9. And, we were doing the snail, right? So this would be 3 to the y equals 9, and we obviously know that the answer there is 2. So another way of doing this problem is to rewrite this logarithm as log base 3 of 3 squared, right? Because 9 is 3 squared. So this is another way of solving the same thing as the snail. So you see how this base and this number are the same? So the property says that basically these guys, they cancel out. So your answer is what remains. Okay, that's just applying a property, a logarithmic property. So the snail method and what I just showed you is the same way to get the same answer. It's different ways to get the same answer. So now, hopefully, when I do this example 1, it's going to make a little bit more sense. So again, the directions say g of x equals natural log of x. Now from the previous lesson, you should remember that natural log, or ln, it means log base of e, right? So now, in replace of x, I'm going to replace it with what it says in the directions here, e to the third. So this, second.
12:18.
So this is log base e of e cubed. And by using the property that I just explained, the answer is just 3. Okay, now pause the video and see if you could do example 2 on your own, how I just showed you. Okay, so example 2, we do g of x equals natural log of x. We rewrite this as log base e of x. And now in example 2, we're told x is equal to e to the negative 2. And then by using the property, we see the answer is negative 2.
We'll be having a fire drill in about 5 minutes. If you require use of the elevator, you're out of luck. Make your way down to the main office now, though. Again, in about 5 minutes, we'll be conducting our fire drill. Please wait for your room to get called.
Okay.
Do not leave off the bell. The drill will last roughly 10 minutes, so have your classes logged back on when we return.
So example 3 and 4, those are the answers. And now I'm going to move on to the last part of the lesson. So the last part, not the last part of the lesson, the next lesson that I taught the class today was this lesson here on properties of logs. So please pause the video, write whatever you want to write from this slide, and I'm going to turn to the next slide and do one example with you. Actually I'm going to do 2 examples with you. So this is called change of base formula. Okay. So in this example here, the first thing I notice is that if I tried to do the snail, I wouldn't be able to, right? 5 to the y equals 8, that can't be done without a calculator. So that's what change of base is to do problems that you can't do without a calculator. So So what we do instead is we use the change of base, which says to do the common log of the number here over the common log of the base. This is equivalent to doing natural log of the number over the natural log of the base. Okay? So this is what change of base means. Now when you put this in your calculator, you got to make sure you put it in parentheses, these things, or else it might give you an incorrect answer. Also, another way, just so you remember, is to always put the base in the denominator. Think of like what a base is. A base is something that holds together. A base is usually located at the bottom. So just remember that whatever your base is, you always put it in the denominator. Okay? This will be approximately 1.29 if you put that in your calculator correctly. Also remember, also just one note, you don't have to do both. You just pick one. Either you can use common log or natural log. An extra example for you to try on your own would be number 10. Pause the video, try it out. And you should get 1.37 here. Okay, so just make sure you would know how to do that. All right, lastly, properties of logs. Oopsie. I was trying to zoom in the properties for you. This is actually all on page 220, so I would say go to page 220 and just copy down your properties. I'm going to do just this first one with you because that's what I did in class today. And that's about it. So the first thing I notice is it says natural log of 6, and it says write each log in terms of ln 2 and natural log of 3. So the number 2 and 3 represent factors of 6. So I could rewrite this as the natural log of 2 times 3. When I look at these properties here, I notice this is the product property, sorry. And so all I have to do from here is rewrite this using the property. So your final answer would be natural log of 2 plus natural log of 3. And that's your final answer. And that's what I got to today. Again, sorry for not recording today. I honestly just completely forgot. So there you go.